All right. So we now want to talk about what is this sort of cumulative aspect of calculus. And to start this off, we're going to start with a simple problem here. Right? So I want to ask for the function f of x equals 4 minus x squared, how much area is under the graph of this from -2 to 2? Right, so this function looks something like this. Right. Let me redraw that part a bit. Right. I want to ask the question, how much area is in here? Okay. This is the question I want to think about. And, well, it comes down to, how could we possibly do that? Now, depending on how well you know your Greek math, I do believe there is a way we can compute this area using some old techniques, but it's not that easy. And if we want to move beyond just a parabola here, then it becomes a lot harder. And in fact, I don't know ways to do that really without calculus. So, how can we start getting at this problem? All right, maybe, let me write here, how much area? Right. So how can we start answering this question here? Well, the best way to do this is the same intuition we kind of used for derivatives, right? Or for finding the slope of a function. We start with what we know, and we push it closer and closer to what the actual answer should be. So remember, for derivatives, when we were trying to find a tangent line or the slope of the tangent line, we drew these secant lines and we basically pushed the secant lines closer and closer to a tangent line. All right, we're going to do something along that same kind of vein here. We're going to approximate with something simple and geometric that we know how to do, and then we're going to push that closer and closer to what the true answer that we're looking for is. Okay, so how do we do this? Well, what's the simplest object to find the area of? Right, that would be a rectangle. Right? I mean, I guess technically a square, but we're going to call it a rectangle here. So what we can do then is take this function. All right, I'm only going to draw this piece of it here. Right? And what I want to do is I want to pile in a bunch of rectangles. Right? But I don't want to just pile them in any old way. Eventually we'll do that, or something kind of like that. But I want some kind of reason to it. So what I want to do here is I'm going to take this x-axis here, and I'm going to cut it into a bunch of pieces. Right? So here I'm going to cut it into 4 pieces. We got the piece from -2 to -1, -1 to 0, 0 to 1, and 1 to 2. All right? So on each of those pieces, what I'm going to do is I'm going to draw a rectangle over it. Now I have to decide how high this rectangle should go. So what I'm going to do is I'm going to use, let me start by using, or let me say in general here, we really can pick any point inside each of these subdivisions here that we made. Right? So what I'm going to do is, out of convenience, I'm going to pick the point on the left side. So if I pick, say for this interval here, the left endpoint, I can draw a line all the way up and then make a rectangle to come down here. Right? Here, I draw a line all the way up to the graph of the function, move over, close that down. Right? And then I can keep doing this. And all right, this one here is just a height 0 rectangle. So I have Actually, let me use a different color to fill in this one. I have these 4 rectangles here. And I can now add up the areas of these 4 rectangles to try and figure out what the area underneath here is. Right? So I'm sort of approximating it by a really simple shape that's really easy to find the area of. Okay. So what we're kind of saying here is that the area this is approximately the areas of these 4 rectangles. Right? So how do I find the areas of these? Well, each of these rectangles here have a width of 1/2, right? Or sorry, of 1. So I'm going to write 1 times, and then I want to write the height of each of these. Okay, so let me remind you here that this function is f of x is 4 minus x squared. So I just need to add up the heights of each of these. Right? So here, the height of this rectangle is 0, because when I plug in -2 to this, I get 0. Oops. Plus, here, when I plug in this endpoint, -1, I get that my height is 3. When I plug in 0, the height of this rectangle, which again is the value of the function there, right? The height of this rectangle is 4. And then over here, when I plug in 1, the height goes back to 3. Right? So this is, 1 times 10. So this is 10. Right? So this area is about 10. Right? Now the true area of this function is actually 10 and, or sorry, the true area of this shape is 10 2/3. So this isn't too bad, depending on, your goal for the approximation here. Right? So we're going to call this L4. Right? This L4 is going to stand for an approximation using 4 rectangles and left endpoints. So this is 4 rectangles, left endpoints. All right. So again, what's gone on here is we added up the areas of these 4 rectangles here. And the reason I could factor out this 1 is all of the rectangles have the same width. So when you multiply this out, we have width times height 1 plus width times height 2 plus width times height 3 plus width times height 4. Right? But again, since I have all the same width, we may as well just factor that out. Okay. Sorry about that. All right. So, in addition to left endpoints, we have a couple other kind of typical choices we can do. All right. We can also do right endpoints. All right, and what are we doing there? Well, it's the same deal, basically. So we have our function. Right. Take our function here. And we're going to cut up the interval in the same way. Cut it into 4 equal pieces. All right. And then when we draw our rectangles this time, instead of using the left edge of each of these intervals, we're going to use the right-hand edge. So draw lines up from all of your right-hand edges, and then make rectangles like this. Oops. All right. Let me fill in the middle one with a different color. All right. So now I want to add up the areas of all these. Okay. So when I do that, so I'm going to call this one, the area, it's approximately R4, right? So R4 is going to stand for right endpoints for rectangles, right? This is going to be, in this case, each of these widths is still 1. So 1 times. Now, to get these heights, we take the right side and plug it into the function. So here, we have f of 1, which is 3. F of 0, which is 4. Oops. F of 0, which is 4. F of 1, which is 3. And f of 2, which is 0. So in this case, you'll see that it works out to be exactly the same as the last one. That doesn't always happen. It happens here if your function is symmetric about the y-axis. That, again, doesn't need to happen. All right. Now, one more type of approximation I wanted to talk about is instead of using left endpoints or right endpoints, we could sort of split the difference and use midpoints. Right? So midpoints, as you sort of might guess, instead of actually picking the endpoints of the intervals, we're going to use the middle. Right? So what does that look like? So most of the process is the same. We're going to cut this into 4 pieces here. We have 4 intervals. And this time, instead of using the left or the right endpoints, I'm going to pick the very middle of the interval and draw my lines up from there. Right? Now, we're not going to connect these as rectangles. This is the middle of the rectangle that we're using. So the actual rectangles we have look like this. They still start and end at these ends of the intervals that we made. Just the middle tells us how high it needs to go. Right? These two should actually be the same height. Just have a bad drawing here. Right, so we have these two should also be the same height. Yeah. Right, so we have something like this. Right, so let me delete these green lines here. Right, so we get something like this now. Right, let me change this. Right. So we want to add up the areas of all these. The process is exactly the same though. Right? Nothing's really changed. So this one here, we'll call this one M4. Right? The widths of all of these are still 1. But now the heights are different now. Right? So instead of using one of these endpoints like -2 or -1, we actually want to use the middle. So let me write out maybe more generally here. This will be f of, this here would be -3/2 plus f of -1/2 plus f of 1/2 plus f of 3/2. Let me move this over here. I forgot how to do this. There we go. Right. Okay. And so, let's see. So plugging in 3 halves, so we're going to get 4 minus 9/4. So that's 7/4. Plus, here we have 4 minus 1/4, which is 15/4. And again, this one's going to be the same. And this will be the same as that one. Right. So that is, let's see, 30. We get 44/4. So 11. Right. So, we get our estimates actually a little bit closer to the true area. Right? Remember, the true area is 10 2/3. Before we were getting 10, now we're getting 11, which is a third closer. It's now over instead of under, but, that's okay. Right? So, in the next video, I will sort of write out a more formalized notion of what's actually being written down here.